Okay, so a particle moves in a straight line with simple harmonic motion. Center of oscillation being O. It says then when the particle is at a distance 3 meters from O, its speed is 6 meters per second and the magnitude of the acceleration is 6.75. Okay, so then in A it says find the time taken to make 6 complete oscillations. Well, we know the formula for finding the time period of one oscillation is 2 pi divided by omega. Okay, so that's for one oscillation. So if we can find that, then we can obviously then think about timesing it by 6, yeah, to work out 6 complete oscillations. So we use the information they've given us, alright? So it says when the particle is at a distance 3 meters from O. So remember, measuring from O, we use the letter x, don't we? So we can say x is equal to 3. We've got the speed is equal to 6. So v is equal to 6. And the magnitude of its acceleration is 6.75. So x double dot for acceleration, yeah? So the size of it is, the magnitude is 6.75. Okay, so let's use this information to try and figure out, in this case it will be omega, won't it? Because we want the time period. So using, let's go with the acceleration formula for magnitude. So the magnitude of acceleration is omega squared x. Okay, so I know x double dot is 6.75. I don't know omega squared, that's what I'm trying to figure out, and I know x to be 3. Okay, so take the 3 over and divide. Okay, and we get omega squared out to be 2.25. Square root then, okay, omega has to be positive, so we take the positive square root. So we get 1.5. Alright, so that's easy enough, yeah? So then we can say, look, the time period is equal to 2 pi over omega. And that'll be 2 pi divided by 1.5. And if you simplify that, it comes out to be 4 thirds pi seconds. Okay, so that's one oscillation. Of course, we want 6 oscillations, don't we? So for 6 oscillations, okay, total time is going to be 6 times this. So if you work that out, that comes to exactly 8 pi seconds. Okay, so that's part A answered there. So for B then, it says determine the maximum speed of the particle. Now I know when it comes to speed, you're going to need to know the amplitude. Okay, and so far we don't have that. However, remember we have these conditions here, yeah? Okay. And we can use these again, okay, perhaps these two, to work out A. So the other formula we've got now, of course, is this formula here. So given that we know that V is 6, okay, we know now omega is 1.5. We don't know A, and we know x is 3 using those initial conditions. Okay, so that's 36, that's 2.25, A squared, and that's going to be 9. Perhaps we'll take that over and or divide through by 2.25. So you get 36 divided by 2.25 is 16. Okay, so then you can see then A squared is 25, which means A is equal to the square root of that, which is 5, right? Again, positive, because amplitude is measuring distance. So then to get the max speed, we really do need to think about this formula again, yeah? And if you appreciate, for this to be at its max, look at, for V to be at its max, look at this here, okay? We need this expression to be at its max. Now, looking at the expression, you're always taking something away, aren't you? X squared. Okay, so we want to take away as little as possible to make this as high as we possibly can. So the least you could take away here is actually 0, isn't it? Okay, x is 0. And we know that when at max speed, x is equal to 0, yeah? We know we're at the center, we know that it's at the center of the oscillation, the mean point when it's at its max speed, it's at its highest speed. So in that formula, v squared is omega squared a squared minus x, 0 squared over x. So v squared is omega squared a squared. So square root everything, so v is equal to omega a. So that's the v max there, yeah? Well, of course, we probably try and learn that formula as well. So then your v max will equal to omega, which we worked out to be 1.5, and your a we worked out to be 5, so that comes out to be 7.5 meters per second.